This Zoom session is being brought to you by the Fractal Heart of Gold. Excuse me. All right. All right. For today, we are going to be doing double angle and half angle formulas. We start with the angle addition laws. Just a second. All right. Cosine of a sum is cosine cosine minus sine sine. Sine of a sum is sine cosine plus cosine sine. And tangent of a sum is tan plus tan over 1 minus tan tan. For the double angle formulas, it suffices to let beta equal alpha, so that alpha plus beta equals 2 alpha. So as a result, plugging in here, cosine 2 alpha equals cos cos, which is cos squared, minus sine sine, which is sine squared. Sine of a double of twice alpha is twice sine alpha cos alpha, because these are the same term. And tangent of 2 alpha is twice tan alpha over 1 minus tan squared alpha. Now, this cos squared minus sine squared we can rewrite using Pythagorean identity. Cos squared plus sine squared equals 1, so cos squared is 1 minus sine squared. We could replace that. And negative sine squared we could replace by cos squared minus 1. So this plus these rules make cosine of twice an angle equals 2 cos squared alpha minus 1, and also 1 minus twice sine squared alpha. So these two cosine rules, well, these three cosine rules, and the sine and this tangent rule constitute the double angle formulas. Now, the advantage of these two versions of the double angle formula for cosine is it allows you to solve for cosine alpha and sine alpha in terms of cosine 2 alpha. So cosine double angle equals twice cos squared minus 1. You add the 1 to both sides and divide by 2. You get cos squared equals cosine of 2 alpha plus 1, all that over 2. Here, a similar bit of algebra. We get that sine squared alpha equals 1 minus negative cosine 2 alpha plus 1 over 2. Now, let's call this 2 alpha. Let's call that theta. So that alpha is half of theta. So cos squared of half theta equals cosine theta plus 1 over 2, and sine squared theta over 2 equals negative cos theta plus 1 all over 2. For the next step, I'm going to flip the order of the, put the 1 plus in front of each of these, and then take a square root. So cosine of theta over 2 is plus or minus the square root of 1 plus cos theta over 2. And sine of theta over 2 equals plus or minus 1 minus cosine theta over 2. Which it is plus or minus depends on what quadrant theta over 2 is in. And similarly, if we take sine over cosine as tangent, then tangent of half theta will be, after dividing this out, comes out to plus or minus 1 minus cos theta over 1 plus cos theta. Now this plus or minus is a minor pain in the neck. It turns out that we can derive, and the book has it on page 244, a formula without any plus or minuses. So tangent of half theta is 1 minus cos theta over sine theta, and it also equals sine theta over 1 plus cos theta. Half angle formulas here, double angle formulas here. So here we're given sine is 3/5, and it's in quadrant 1. Find sine and theta of twice theta, sine and cosine of twice theta, and sine and cosine of half theta. Now, all right, we first draw the triangle in the quadrant 1. Sine is 3 over 5. This third side is 4 by Pythagoras. So you read off that sine theta equals 3/5 and cos theta equals 4/5. All right, now from that along, we get sine of and cosine of 2 theta. Sine 2 theta is 2 sine theta cos theta. That's twice 3/5 times 4/5. And after some arithmetic, that's 24 over 25. Cosine of 2 theta is, well, among other things, let's do 1 minus sine squared theta. You could also have it sine squared minus cos squared, or 2 cos squared minus 1. It's generally better to use the, as it were, freshest ingredients, to use as few derived quantities as possible, because errors could accumulate. So cos 2 theta is 1 minus twice sine squared. That's 1 minus twice the square of 3/5 after some arithmetic. That's 7 over 25. Now, for theta over 2, you have to know which quadrant theta over 2 is in. Theta is in first quadrant. Half theta will also be in the first quadrant. So therefore, you get plus in both cases. Sine theta over 2 is 1 minus cosine, all that over 2, plus the square root, that is. So square root of 1 minus 4/5, all over 2, which comes out to, after some arithmetic, root 10 divided by 10. Cosine of theta over 2 is a plus the square root of 1 plus cos theta, that over 2. So the square root of 1 plus 4/5, that over 2, which after some arithmetic is 3 root 10 over 10. Now here, we're asking after cosine of 165 degrees. All right. So 165 degrees is in quadrant 2. So I think this is an error here. I think what we're trying to do is this is half of theta 165 degrees is twice is 330, which is quadrant well, whatever. It's in quadrant 2, so its cosine is negative. And 165 is half of 330. So we can write this as cosine of half of 330 degrees. So be a minus, because 165 is in quadrant 2. 1 plus cos 330 over 2. And so 1/2, 2/2. Okay. That's 1 plus root 3 over 2. Minus 2 plus root 3 all over 2 after some arithmetic. I'm going to have to check this. Here is an identity to prove. And as usual, you really need to show all the steps to prove an identity. So sine 3 theta over theta minus cos 3 theta over cos theta is 2. Prove that. All right, just a second. So sine 3 theta and cosine 3 theta. Well, okay, let's put this all over a common denominator. So it's sine 3 theta cos theta minus sine 3 theta cos 3 theta over sine theta cos theta. All right, now sine theta cos theta is, well, we'll get to the double angle. Here, we'll multiply above and below by 2. Now sine cosine minus sine 3 theta cos theta minus sine theta cos 3 theta is sine of 3 theta minus theta. And put a 2 over 2 above and below. This is sine 2 theta. This is 2 sine theta. 2 sine theta cos theta is sine of 2 theta. And the 2 theta, sine 2 thetas cancel out, leaving a value of 2, which equals the right side. And that's done. Okay, that's that for that. Next time is, I think, a particularly interesting one. Product to sum and sum to product formulas. We use the angle sum and angle difference formulas, and from them derive what I call a product and sum identities, where a sum of sines and cosines equals a product of them. And then after a bit of division, dividing this side by 2, you get that a set of products of sines and cosines will equal half a sum or difference of sines and cosines. That's the product to sum formulas. Or from here, we do a variable substitution and get the sum of cosines or difference of cosines or sum of sines or difference of sines is equal to products of cosines and sines. That's the sum to product identity. Now, if you have, this will yield what are called beat formulas. You have 2 sine waves and you play them both at the same time, so you get a sum of them. Then the result has a beat. It is a wave with average frequency modulated by a much slower wave of half difference frequency, that being the beat. We'll get to that next time, however. Okay, just a second. And let's call this done. All right, now we have done our section for today, 3.6. We'll get to 3.7 on Thursday. I open the floor to questions, comments, requests, and suggestions. Very well then. Motion to adjourn. Is it seconded?
Seconded.
Thank you.
Indeed.
Thank you, Professor.
Thank you. I'll see you on Thursday. Good morning. And I also will be having an office hour on this site from 11 to noon today. for those who wish to ask questions. Very well then.
Thanks, Professor.
No problem.
Dear Professor.
I noted you down.
All right. Thank you, Professor. Have a good week.
You too.
All right. Bye-bye.
Bye.
Hello, Professor.
Yes. Hi.
Yeah, I want to say I'm very sorry. Sometimes Thursday I forgot there is a class, so I miss maybe 3 times on Thursday.
I see. Yeah. Oh well. I mean, you can find the Zoom session recorded on the Canvas. If you need.
Yeah, I know that. So
Okay.
it's the where influence my grade or not where not pass the class.
I don't believe in seats in chairs. What I grade on is the work you send to me that I can objectively look at. Okay.
Okay. Thank you, Professor.
No problem. I'll see you later.
Okay. See you. Have a good day.
You too. Bye.
Okay. Bye.